So in this video we're going to cover Newton's forward and backward interpolation. That is the first topic under interpolation. If possible, I will try to cover Lagrange interpolation also in this video, right? Yes. So we will start Newton forward and backward interpolation. So first we will start with the Newton forward interpolation formula. So first I'll let you know how to apply or when to apply Newton forward interpolation, right? Yes. So suppose for example, so they will give a set of values. For example, let us say this is year and this is population. I'm just taking some example, right? So for example, let us say in 2000 the population for some city, right? It is just say it is 1 lakh, right? And in 2002 let us say population is 1.2 lakh, and in 2004 let us say it is 1.6 lakh, and 2006 let us say it is 1.9, right? And let me add some more also. In 2008 it is, let us say it is 2 lakh. Now what will be your population in 2001, right? We are going to interpolate, right? So they are given the data for 2000 and 2002, but we didn't know what will be the population in 2001. It will be somewhere between 1 lakh and 1.2 lakh, but we don't know, right? Now in Newton forward interpolation formula, we are going to interpolate these values. That is, we are going to estimate what will be the values between these 2 years, right? I'm just taking this for example. Suppose if they are asking us to estimate what will be the population in 2001, and you just break this into 2 halves, and this is first half, this is second half, right? So you just break this into using middle point. So here we have 5 set of data, so you just you just take 3 or 2 as your middle term. So you just take 3 as middle term. So I've just splitted this data into I was just segregated in 2 parts, and they are asking what will be the population 2001. And since it lies in the beginning of the table or it lies in the first part of the table, you use Newton forward formula, right? Newton forward interpolation formula. Suppose if they ask us to estimate what will be the population 2007, you can see 2000 lies in second part, right? 2000 lies in second part, that is the second middle part. So you can estimate this using Newton backward interpolation formula. Both are same. So if our unknown data, the data which they are asking lies in first part, you just use Newton forward interpolation formula. If it lies in second part, you use Newton backward interpolation formula, right? You get more approximate result when you use Newton forward interpolation formula when the asked data lies in the beginning of the table, and you will get more approximate data or a more accurate data when you use backward interpolation formula when your unknown data lies in second part of the table, right? So this is the introduction to Newton's forward and backward interpolation formula. Now first we will I'll give the formula for Newton forward interpolation formula. We will do 2 problems, and then I'll give formula for Newton backward interpolation formula. We will do 2 problems, right? Very easy, again very elementary. So this is the overview for Newton forward and backward. We are just going to interpolate what will be these data, right? Yes. So again very simple, right? So let us take for 1 it is 2, for 2 it is 4. It is like aptitude question. For 3 it is 7, and the important thing is the interval has to be same, right? The interval width has to be same for when you are applying Newton forward and backward interpolation formula. So the interval width, you can see the interval width is 2000, 2002, 2004. You can see every interval length is 2, right? So interval length has to be same when you are applying Newton forward interpolation formula, right? And for backward also the interval has to be same, the interval width has to be same. Suppose if the interval width is not same, you should use Lagrange interpolation formula, which is the second method in the syllabus. The intervals are same, that is the interval width I am asking. I'm talking about the width of the interval. If the width of the interval is same, you can use Newton forward and backward interpolation formula. Depending upon the unknown value, if it lies in the first part, use forward. If it lies in the second part, use backward. And if the interval width is not same, for example, if you consider this 2000, 2005, 2007, 2010, you can see the interval width is not same. Here the width is 5, here the width is 2, here the width is 5. So interval width is not same. So you cannot use Newton forward or backward interpolation formula. If the interval width is not same, you should use Lagrange's interpolation formula, that we will talk later, right? So first we will talk only about Newton forward interpolation formula, right? So I'll tell you the formula first. I'll give you the formula. So first you will see Newton forward and then you will see Newton backward. So Newton's forward interpolation formula. So I'll give the formula. So y of x is equal to x naught plus nh. Y of x is equal to x naught plus nh is equal to y naught plus n by 1 factorial del y naught plus n into n minus 1 by 2 factorial del square y naught plus n into n minus 1 n minus 2 by 3 factorial into del cube y naught and so on, right? The next term will be n into n minus 1, n minus 2, n minus 3 divided by 4 factorial into del power 4 y naught. So it will go on and on, right? So this is the formula for Newton forward interpolation formula, right? Yes. So if you know y naught, n and del y naught, del square y naught, you can able to find the unknown. Here the unknown is x, right? Here that is the number which they are asking us to find is our x, right? So I'll do with problem. It will be very easy for you. So let me do one problem, and then if you understand the problem, it will be very easy, right? So problem. So using Newton formula for interpolation, so find population at 1905. The question here, population. So 1891, it is 98,752, and in 1901 it is 1,32,285, and in 1911 it is 1,68,076, and 1921. So can anyone send class link for it? I'm sending a message to send class link. So 1921 it is 1,95,670, and in 1931 it is 2,46,050, right? So this is the question. So they are given the year and population. So in 1891 the population is 98,752, and in 1901 it is 1,32,285, and they are given, and you can see the interval width is 10 years, right? Interval width is 10. Now we need to estimate the value at 1905, that is the unknown lies in the first part, right? Now we will use Newton forward interpolation formula. Yes. Solution. Now you can see first we need to find we need to find del y naught, del square y naught, del cube y naught, and so on, right? So whenever you are given the table, so first you need to find difference table, right? So first you need to find difference table. So difference table, so very easy table. So first we start with x, and then start with y, and then del y, and then del square y, and then del cube y, and so on. So this is our column. So x, what is x? So you just write, you just take this x, this is y. So this is 1891, 1901, and then 1911, and then 1921, and then 1931. This is the x. First we need to find a difference table. So it is x, y, del square y, and so on. So y they are given as 98,752, 1,32,285, and then 1,68,076, and 1,95,670, and 2,46,050. Now you just take calculator, and then you said subtract this term and this term, right? That is 1,32,285 minus 98,752. So you just subtract these two terms. So you will have 33,533. So you just write in middle of this 33,533. Now again you subtract this term and this term. Now you subtract this term, you subtract 1,60,076 minus 1,32,285. So you will have 35,791. 35,791, and you subtract 1,95,670 minus 1,68,000. So you will have 27,614, and subtract this term and this term, you will have 50,360, right? And again you subtract this term and this term. So 35,791 minus 33,533, so it is 2,258. Subtract 27,614 minus 35,700, it will be minus 8,177. You should always subtract this term and this term, right? It can also have minus, and it will be 22,746. Just subtracting